How do we listen and speak at the same time over a communication channel? How does a telecom operator decide which duplexing method to use? Will the device that you use in China work in other parts of the world? Hi everyone, welcome back to the world of long-term evolution, 4th generation communication system. Today we will be discussing about duplexing.
Duplexing is the process of achieving two-way communication over a communication channel. It can be a half duplex or a full duplex. Half duplex. It stands for one-way communication at a time, which means the other party has to listen when you are talking, and you have to listen when other party is talking. So friends, do you have any device in your mind that uses half duplex communication? How about a walkie-talkie device, having a push-to-talk feature? Now, let us look at second mode of communication, full duplex. It stands for simultaneous communication between two parties, which means both parties can interact freely. Now let us see how it is implemented in LTE, long-term evolution. Frequency division duplexing, FDD, is a method for establishing a full duplex communications link that uses two different radio carrier frequencies for transmitting uplink and receiving downlink. Both the channels are separated by a defined offset frequency, which is also known as guard band. The main purpose of selecting a guard band is to stop the interference between uplink channel and downlink channel. Now moving forward to TDD. Time division duplex is a technique by which the uplink and the downlink transmissions are carried over the same frequency by using synchronized time intervals. For example, a TDD communication path has been set up between Krishna and base station. Krishna can alternatively transmit and receive over time. Krishna using time slot 1 to transmit, slot 2 to receive, slot 3 to transmit and so on. Exact opposite with base station. As the transmission periods are relatively short, no time delay is noticed on voice transmissions. In between time slots, there are certain guard periods, so that signals traveling from base station can arrive at Krishna before the Krishna starts transmitting.
Let us see what are the factors that helps an operator to decide whether to use FDD or TDD before rolling out a full-fledged low latency. FDD offers very low latency, since transmit and receive functions operate simultaneously and continuously, whereas in TDD switch from transmit to receive incurs a delay that causes traditional TDD systems to have greater inherent latency. Equipment costs. No duplexer is needed to isolate the transmitter and receiver in TDD, whereas in FDD duplexer is needed. This is a key aspect, as cost of the user equipment is of major importance because of the vast numbers that are produced. TDD has the advantage here. Distance preferability. As the distance increases, the guard period also increases in TDD because the point-to-point signal propagation time increases. The increased guard period significantly affects the efficiency, whereas FDD does not have a problem with small or large distances. Unbalanced traffic. In real-life, network volume consumed in downlink is much higher than in uplink. In TDD it is possible to dynamically adjust the capacity by utilizing more time slots for downlink than in uplink, whereas in FDD, the capacity is normally balanced in both direction. Spectral efficiency. TDD uses only one frequency, whereas FDD uses two different frequencies. So spectral efficiency in FDD is not as good as TDD. MAC layer complexity. MAC layer in TDD system is complex compared to FDD system, as it has to deal with accurate time synchronization between the systems, whereas in FDD there is no uplink and downlink switching mechanism at timescale.
Ultimately it depends on the network operator to choose as per requirement, convenience or feasibility. As far as LTE is concerned, it is defined to support both the paired spectrum for frequency division duplex and unpaired spectrum for time division duplex. There is same 3GPP specifications for both duplexing method, 3GPP 36.847. While the majority of the global LTE market is based on FDD technology, TDD is expected to see increased adoption in the US, China, Australia, Middle East, Northern and Eastern Europe, and Southwest Asia to gain a more pronounced position in the global LTE market. Keeping an eye on the future market, modern devices are being manufactured with support for both time division duplexing and frequency division duplexing.
So, next time when you buy smartphone, check which technique is used by your service provider and check the frequency bands supported by your smartphone. In the next video we will talk about shared medium technique, which is multiple access. So friends, don't forget to subscribe to our channel, like our videos and comments your views or suggestions. Thanks for watching.